Hi, my name is Mr. Chu. You are welcome to my study room. Please subscribe to this channel if today is your first time coming here. Being the study guide to a number of students, I take regular reports from them, and two of the common challenges that keep coming through are how to solve word problems and then also algebraic expressions, which includes expansion and then factorization. They keep coming through every year when I want to take reports from my students. Because of these feedbacks, I decided to title today's studies All There Is to Know About Algebraic Expressions. It's mainly going to be about the basic things we need to know in order to solve algebraic expressions. Please come along with me. Thank you. Before we go to algebraic expressions proper, let's take some few tips. In algebra, letters and symbols are used to represent numbers or quantities we don't know yet. When letters stand for different numbers, they are called variables. Letters and symbols which have fixed values are called constants. Example of such a symbol is pi, which we all know to be 22/7 or 3.142, depending on how many decimal places you want to earn it, because it's a non-terminating decimal. Also, numbers are also constant. Numbers can also be constant, not only symbols. For example, in the expression 2 pi r square h, the 2 here is a constant. The pi here is also a constant, and the r and the h are variables because they can assume other values depending on the question we are solving. But with the 2 and the pi, their value will remain the same no matter how the question is turned. That is why they are constants and the r and the h are variables. Given all this fact, let's come back to algebraic expression proper now. Algebraic expression is when letters or symbols are combined with at least one of the basic operation signs. And these basic operation signs, I hope you know them. They are addition, multiplication, subtraction, and division. They are addition, subtraction, multiplication, and division. These are the basic operation symbols or the basic arithmetic operations. When one or more of these four operations combine letters, symbols, and numbers, then we will call that an algebraic expression. Let's take some examples of algebraic expressions. Five ABC is an algebraic expression. 2a squared bc cube is also an example. We can have 8x minus 7y minus 3. That's another example. And we can also have 2x squared y plus 6x y squared as examples of algebraic expressions. Usually in writing algebraic expressions, multiplication and division are not written. So for example, if you want to write P times Q, you simply write PQ, meaning the P is multiplying the Q. The same way, if you want to write P divided by Q, you simply write P over Q, meaning they are dividing. We can also have x, y, z over p, q, r. And this, the meaning of this is x, y, z divided by p, q, r. Alright, so anytime you see the quotient or fraction of two algebraic expressions, it means they are dividing. The same way, when you see a number of letters or symbols together in algebraic expression, it means they are multiplying. So when you are giving the value for each of them and you are to substitute them into the expression, it means you are going to multiply the numbers you substitute into the expression. So this is something also you have to note. The next point we need to notice: terms in algebraic expressions are separated by plus or minus sign. Example: negative 2x squared y plus 6xy squared has two terms because they are separated by an addition. I just said that terms are separated either by addition or subtraction signs. If you have addition or subtraction between two expressions, then you can call each of them a term. So in this example here, there are two terms. Negative 2x squared y is the first term, and 6xy squared is another term. Also, 15mxy minus 10m squared plus 2my minus 3xy has four terms because 15mxy is the first term, negative 10m squared is the second term, 2my is the third term, and negative 3xy is the fourth term. The same way, 7pqrst has only one term, though the letter combinations are many, but it has only one term because there is no other term closer to it which is separated either by an addition or subtraction sign. Because of that, the way it looks here a bit longer than any of the earlier examples, but it has only one term because they are not separated by addition or subtraction. A term which has only a number with no letter or symbol attached to it is called a constant term. The example, 3x squared y plus 7x plus 5. I will first go back to the earlier point that these are three terms, but then this third term is a constant term. It's a constant because it has no variable attached to it. To break everything down using this, we can call this and this coefficients. We can call them coefficients, and then this and this, we can call them variables. And then the one standing alone is a constant term. A number without any variable is a constant term. So a number attached to a letter or combination of symbols or letters is called a coefficient, and then the letters or symbols themselves are called variables, and a constant, as explained earlier, is when the value is fixed. So numbers standing alone qualify to be constant terms. Let's go ahead with more tips. When writing terms, numbers come first, followed by the letters in alphabetical order. That is what is normally done. For example, TP squared 12mq is better written as 12mq p squared t, because the numbers have to come first as coefficients, then followed by the letters in alphabetical order. Let's take a few more tips about algebraic expressions. The number placed in front or multiplying letters in group of letters is called coefficient. I said that earlier. Every term goes with the sign it follows. For example, in 4w y plus 9xy minus 6xy minus 6wz. The first term is 4wy, the second term is 9xy, but the third term is negative 6xy, and the fourth term is negative 6wz. Also, in an example, 3PR minus 6PS minus QR plus 2QS. The first term is 3PR. The second, negative 6PS and not PS. The third, negative QR. And then the fourth one, 2QX. In algebraic expressions, like terms are terms with the same letter combinations. So you see that when we are working, we mostly say group like terms or add like terms or simplify like terms. So when we say like terms in algebraic expression, we are just talking about terms. Now we have learned what terms are. So we are just talking about terms that have the same letter combinations or symbol combination. For example, we will say that X, Y, Z and 5X, Y, Z are like terms because both of them have the same letter combinations. The same way, 2A squared B and 5A squared B are also like terms because they have the same letter combinations, A squared B, A squared B. So that is the same letter combination. Then 3A squared Y and 3XY squared are not like terms. They are not like terms because we have the same letter combination, but the X here is squared and it is not squared here. The same way the Y here is not squared, but the Y is squared here. Because of that, they are not like terms. They become like terms only if the X is squared here and it is squared here, and the Y is squared or not squared here and the same thing appears here. But because the exponent vary, we will say that they are not like terms. So that is what it is. Then let me quickly add that like terms can be added or subtracted. Like terms can be added or subtracted. Going back to the examples I gave earlier, you see that because we said this and this are like terms, we can add them to give us X, Y, Z plus 5X, Y, Z will give us 6X, Y, Z. Because every variable standing on its own or combination of variables standing on their own without a coefficient has a coefficient of 1. So this is the same as 1xyz plus 5xyz, and that will give us 6xyz. Same way, we can subtract these two because I said they can be added or subtracted. So 2a squared b minus 5a squared b will give us negative 3a squared b because they are like terms. So you have 2 of the a squared b minus 5 of the a squared b. It will give you negative 3 of the a squared b. Or in more basic explanation, you can take the combination of variables as any tangible thing in mind. So let's say you have 2 apples or mangoes, and then negative means you are owing another person 5 mangoes, the right thing for you to do is to use the 2 you have to go and pay the person, and you will still be owing 3. So that is how it works. We can take more examples on this addition and subtraction of algebraic expressions so that we get to understand well. So let's simplify the following. Question 1 is 2x plus 3y minus x plus 5y. To get answer for this, we have to group like terms. So the like terms are 2x and negative x, and then 3y and 5y. We can add or subtract like terms depending on what the question is giving us. So 2x minus x is going to give us 1x, which is written as x. Then 3y plus 5y will give us 8y. The same way, 4a and 6a are like terms, so we can add them. So 4a plus 6a is going to give us 10a. The same way, 3b and negative 8b are like terms. So 3b minus 8b will give us negative 5b. Then we go ahead to question 3. We have 3xy and negative 2xy, as well as xy, which is the same as 1xy, as like terms. So let's simplify them quickly. Let's simplify the x squared terms first. It doesn't matter which one we prefer, but let's simplify the x squared term first. So 5x squared plus x squared will give us 6x squared. The same way, 3xy minus 2xy will give us 1xy, which is the same as xy. Then plus xy here will give us 2xy. Here, the like terms are x squared y, or 2x squared y minus 4x squared y, as well as 5xy squared plus xy squared. So 2x squared y minus 4x squared y will give us negative 2x squared y. The same way, 5xy squared plus xy squared will give us 6x y squared. Up next are a few questions for you to simplify by either adding or subtracting. Feel free to pause the video and answer them. Don't hesitate to share the answers with me in the comment box. And this is where we'll end today's studies on all there is to know about algebraic expressions. That looks like an elaborate introduction to algebraic expressions. Alright, in my next video, we are going to learn how to form algebraic expressions ourselves. I think that is where most of the problems have been coming from. And since at the beginning of this lesson, I said algebraic expressions are formed by using letters or symbols to represent unknown quantities. we are going to learn how to represent these unknown quantities using our own letters and symbols. So I want to encourage you to subscribe to this channel if you haven't done that yet, so that when these videos come up, you can be quickly updated to follow. Thank you for making time with me, and I hope to see you again. Bye bye.